Hi everybody. I wanted to go over what we talked about in class last time, which is um, getting some intuition about how limits work. So this whole um, section of the course is all about limits, and the way I think about a limit is what should the function, what should the value of the function be at a particular point. What should the value of the function be if we ignore what's happening at that point? So let's talk about Oracle 1. And when we started to plug in, we said let's plug in 2 and see what the Oracle gives for 2. And the Oracle tells us that there's no actual value for f of 2. So if we're coming up, so this is for Oracle 1, if we're coming up with a list of values and we plugged in 2, there's no value for 2 in this function. So we tried in some other values. So maybe if we plugged in 1, we got 3. So for this is our x. What is f of x? 1 gave us 3. 0 gave us 2. 3 gave us 5. And 4 gave us 6. So we had a pretty good guess. We had a pretty good guess that the function value for 2 was going to be equal to 4. So that's our initial guess. F of 2 is equal to 4. But let's make sure by zooming in really close. So let's try values like 1.9. If we plug in 1.9, so let's create a new table here, the actually closer table, x, f of x. If we plugged in 1.9, we got 3.9. If we plug in 1.99, we get 3.99. If we plug in 1.999, we get 3.999. Alright, this really does feel like as you get closer and closer to 2, on the lower side, we get closer and closer to 4 on the upper side. Let's actually come down from the other direction too. If we come down and we say, what about 2.1? 2.1 gives 4.1. What if we put 2.01? Well, that's going to give us 4.01. What if we put 2.001? 2.001. We get 4.001. So it looks like the closer and closer we get to 2, the closer and closer the function value gets to 4. So this is pretty good evidence. From that. Alright, let's go on to the next oracle. Each one of these oracles brings something different into the discussion. So Oracle 2. So in Oracle 2, what did we learn? 2. We're trying to figure out what g of negative 1 is. So what is g of negative 1? This time let's plug in negative 1. What do we get? Oh, we get an answer. We get that the answer, so x, g of x, when we plug in negative 1, we get 0.2. Oh, so maybe that's what the function is supposed to be. Let's try to plug in some other numbers. 0. Oh, that gave us infinity. Oh, that's not a number, but we'll take that data. 1, we get negative 0.33. negative 2, we get 0.16, and negative 3, we get 0.111. Oh, so at first glance, all right, we'll make a guess that g of negative 1 should be 0.2. But let's get closer to that. Let's do some more tables. And so where are we? We're at negative 1. So if what's a little bit less than negative 1, we'll have negative 1.1, negative 1.01, negative 1.001, dot, dot, dot. And if we had x, g of x, and then we wanted to go from the positive direction, we would maybe start at negative 0.9, negative 0.99, negative 0.999. Let's figure out what the oracle gives us for those. Negative 1.1 gives us 0.303. Negative 1.01 gives us positive 0.330033. 1.001 gives us 0.333. And then from the other side, what do we have? We have 0.9 gives us 0.37037. Negative 0.99 gives us 0.3367. And 0.999, negative 0.999 gives us 0.333667. Oh, that's surprising. That's not what our original guess was. Instead, what we're seeing here is that when we're near negative 1, g of negative 1, when we plug in the value negative 1, we get 0.2. 0.2. So 0.2. So this is negative 1. But when we're very close to negative 1, the function value actually seems like it's getting closer and closer to negative, to positive 0.3333. So if we were to maybe graph what this looks like, what we would see is that this function, everywhere except for for x equals negative 1, we get points that lie on a curve, but at exactly negative 1, the function pops over to something else. So, it seems like a better value for g of negative 1 is 0.3333 or a third. Okay, so that's what's happening in Oracle 2. Even though the function has a value there, that doesn't mean that that's the best value if we ignore what's happening at that point. Alright, let's go on to the next oracle. Alright, let's find the best function value for h of 1. Alright, so oracle 3. Alright, we're trying to find h of 1. Let's plug in 1. What do we get? We get 3. Okay, but that we now know that maybe that's not the best value for the function there if we're ignoring what's happening at 1. So let's plug in some values. We're going to plug in 0. 0 gave us 0. We plug in, actually let's plug in negative 1 as well. So negative 1, so 0 gave us 0, negative 1 gave us 1.8, 1 gave us 3, but remember, we don't care exactly what's happening there, we care around it. If we plug in 2, what do we get? We get something huge. And if we plug in 3, we get something even huger. So I don't know what the actual value should be. So we don't know what makes the most sense there. So let's now maybe get closer to 1. So again, we need to really zoom in here. So numbers that are close to 1, let's try 0.9, 0.99, 0.999. So the 0.9 gives us 0.000478. Let's try 0.99. That gives us, oh my gosh, 0.6588. 0.999 gives us 1.628. What about 9999? 0.9999 gives us 1.782. Put in another 9. 0.99999 gives us 1.7982. Let's try another 9. Another 9. Another 9. These numbers look like they're getting closer and closer to 1.8. So 1, 2, 3, 4, 5, 6, 7, 8. So those numbers get closer and closer to 1.8. What happens if we look from the other side? What if we look at 1.1? That gives us 24,805. We know that we need to get really, really close. So let's go 1.0001. 1.00001 gives us 1.8018. Ooh, it looks like we're getting really close to 1.8. This looks like it's getting really close to 1.8. So even though the function value gave us 3, what it looks like is this is a graph where the numbers are really tiny and then they get really big really fast. And the function value is actually 3. But what the function should be looks like it's about 1.8. All right. Let's look at oracle number 4 here. So oracle number 4. Oracle 4, let's try to figure out what the best function value for f of 0 is. So let's plug in 0, and we realize, right, plugging in 0 doesn't actually tell us anything because we need to look at what's happening on either side of 0. So f of 0 is equal to 42, but is that the best? Okay, so let's plug in -1. So we get -1 gives us -1. Going to -2 is not getting closer, so let's go even closer. -0.1. So -0.1 gives us -1. -0.01 also gives us -1. What about 0.0001? Also gives us -1. Oh, well maybe the function value is -1. Now let's look at what happens on the other side. What happens if we plug in +1? Oh, that's giving us +1. What about 0.1? 0.1 gives us also 1. What about 0.0001? Gives us 1. So that's telling me that it really looks like this function does this. When you're less than 0, the function value gives you a -1 value. When you're greater than 0, the function gives you a +1 value. But when you're actually at 0, you get a value of 42. Um, so what should the function be? Well, um, should it be 0? Should it be 1? Should it be -1? Um, I think maybe there's no good answer. There's a good answer if we're looking at it from the left side. There's a good answer if we're looking at it from the right side. But that doesn't mean that there's a good answer uh, actually at x equals 0. So what we'll learn what this is going to imply. We're going to say the limit of capital F of x at x equals 0 does not exist. We will talk a little bit more about that later. All right, now let's go on to Oracle number 5, and let's see what we can learn about that one. All right, so let's see. We're trying to figure out what g of 0 is. So x and g of x. Now we've tried this before. We plug in some values, and we want to be close to 0, so maybe 0.1. And if we evaluate that, we get 0. What about 0.01? 0.01 also gets 0. What about 0.001? All right, 001 also gives us 0. Let me put in some more. Well, this one gives me a number that's really close to 0, so I'm going to just guess that it's equal to 0. 0, 0, 0, 0, 0, 1 gave me a 0. Maybe we'll try another one just to be careful. Also giving us this number, a number that's not exactly 0. Another number that's not exactly 0. These numbers, they kind of, I don't know, let's see, this is 0, 0, 0, 0, 0, 1, lots of zeros, and I get negative 2 zeros, 0.00000223. Okay, there's something happening here. I'm not exactly sure, but maybe that's just an error in the computer. So let's try from the other side. X, g of x. If we maybe plugged in negative this value, what would happen there? Also getting this, so negative 0.0001. I get some zeros, so negative 0.10, so maybe you can fill in some of these data points. But it looks like something else, something weird is happening here. But maybe a best guess is that g of 0 is equal to 0. What if we just tried a different number? Maybe I tried 0.00003. Wait a minute. 0.866? Wait, so if I put in here 0.00003, I get 0.866025. That's not close to 0. But if I put a 4 in here, well, that gives me 0. What if I put a 6 in here? Another 866. What if I put a 7 in here? 0.781? Okay, something weird is happening here. If I put in maybe 0.0078, 0.39, if I put in a lot of zeros, maybe it's just I didn't get close enough. This answer is almost -1. Oh my gosh. So 7.8 times 10 to the negative 11th gives me negative 0.999. The numbers keep varying widely. No matter how close x gets to 0. And so let me do one thing here, which is to draw this picture of what this graph looks like. So if I go to Desmos, and I'll draw the equation of the graph that I put in here. Like sine of pi over x. Let's take a look at what sine of pi over x looks like. Sine of pi over x. All right, let me zoom in here and let's see what's happening. Let me move this out of the way. If I zoom in here, look at this function. This function is going up and down, so away from 0, it just behaves kind of nicely. But as you get closer and closer to 0, this function goes up and down infinitely many times. It goes up and down infinitely many times as it gets closer and closer to 0. So that's really telling us that this function, there's no good answer for what it would be at 0, because it just bounces up and down infinitely many times, going between 0 and 1, 0, and between -1 and 1, -1 and 1, infinitely many times. So again, what we're going to say is that this limit does not exist. Okay, in the next video, we'll build a little bit more intuition, graphical intuition about what's happening with this idea of a limit, and then we will talk about the definition of a limit. All right, so talk to you later. Bye.